So this is going to be the video for homework number 4, question number 7. And what they give us is a graph of a function f of x, and they ask us 3 questions about that function. So I've kind of drawn my best representation of what they showed us. And so the orange line here is f of x, and this guy here is the y-axis, this guy here is the x-axis. And the first question they ask us, part A, says, does f of x have a limit at x equals a? And I remember I told you guys that one of the ways you can check to see if there's a limit is to put your fingers on both sides of the function and trace towards a. And if your fingers are going in 2 opposite directions, if they're not kind of pinching on a point, that's a definite sign that there is no limit at that point. Because it's not, it's going to 2 very different places, as different as it can possibly be when you get to A. So there's no one place that they're headed. So the answer for part A is no. There is no limit at x equals A. If it was a different function that kind of flowed smoothly, you could kind of pinch your fingers together and get a nice smooth point there, you stand a much better chance of having a limit under those circumstances. But in this case, we're going off to negative infinity on one side, positive infinity on the other side. There's just no limit. So the next question is part B, is f of x continuous at x equals a? Okay, well, what was the continuity test that I taught you? Start with your finger on one side of the function and trace all the way over to the other side, and if you have to pick up your finger, the function is not continuous. Okay, I can't even trace to negative infinity here. I'd have to pick up my finger and start over at positive infinity and come back over there. So I had to pick up my finger to trace the function. So the function is not continuous at x equals a. So for part B, the answer there is no. And finally, is f of x differentiable at x equals a? So that's kind of a different question than you've been asked in the past, but one of the things that you need for something to be differentiable, for you to be able to take a derivative, is you need a point on that particular function where you can do a tangent line. So if I wanted to do a tangent line here, it looks something like this. If I wanted to do a tangent line at this point, it would be something like that. But you have to have a point on your function for you to be able to take that particular derivative there. And in this case, we just said it never actually touches a. There's no point at a that we can take that derivative from. So the answer for C, is f of x differentiable at x equals a? Well, the answer for that one is also no. And that's because there's just no point that you could actually take a derivative at. And that is the end of this one. If you still have questions about it, these are some slightly higher concepts than what we've been doing before. If it doesn't make sense, shoot me an email and we can talk about it. I can show you a few different examples of things that are differentiable as opposed to this particular example here that they gave us that's not differentiable.